Ramesh sir, shall we start the session? Ramesh sir? Sir,
Yes, sir.
shall we start the session?
Yeah, yes, sir.
Actually, ma'am will join, okay? Should we call her?
Actually, ma'am, I think no, sir. Ma'am, and interview panel, sir.
Okay, okay,
Ah.
fine. Better we start. So we'll start, sir. Honorable Head of the Department and dear faculty members, my dear students, good afternoon to one and all. It gives me an immense pleasure to welcome you all for this webinar on IoTifying India Tiny Machine. Okay, it's going to be preloaded as like a multi-technology IoT device. We'll be speaking more about that. It gives me an immense pleasure to welcome Mr. Jackson. Mr. Jackson is a renowned data scientist and data engineer working with Prompt Cloud Solution Bangalore. He is experienced in IoT, data engineering, skilled in data science, market research, data visualization, NoSQL, and cloud infrastructure. Let me welcome Mr. Jackson to take over the session and address our others gathered.
Thank you so much, sir, for welcoming me on the session. And also, I thank you for giving me this opportunity for this webinar on IoTifying India. So I hope I'm audible to everyone.
Yes, you're audible.
Okay, good.
Yes, audible.
Okay. So, as sir said, like I am a senior data engineer and a data scientist working with Palm Cloud Technologies Bangalore. And in this webinar of IoTifying India, like today we'll be having an idea of how IoT can change the entire world, what we live in, and how it can change the way we think the world would be in 5 years or in 10 years. So let me share the screen and take you guys to the presentation so that it would be really interesting to start. So I believe everyone can see my screen. If you can't see the screen, you can ping here or you can inform
Screen
me.
visible, sir.
Okay, great. So in this session of IoTifying India Tiny Machine Vision, the title itself speaks like what are we trying to achieve and what could be the future of IoT. So we come understanding that IoT is like connecting like multiple machines together or like multiple tiny devices together. So ratherly when we generally say IoT, it means like connecting the sensors together or like that's it. But it's more than that to it. It's like a lifestyle changing when it come to real world experience. So before moving on to IoTifying India, let's have a look at like how life feels when IoT is completely enabled in next 5 years or like in 10 years in the upcoming future. So this video is like 2 to 3 minutes long. Before I'll give a short intro of how IoT looks like. So, before getting into the session, can anyone have any idea about like what is IoT, Internet of Things? Can anyone come up and speak? Like, do you know any idea of IoT or like what it can be achieved? Do anyone have anything to say? Like,
IoT is an interconnected devices with internet as backbone.
okay, Internet as a background, it's an interconnected devices. Great. Anyone else? Good. So let's go on to this video and check out how the lifestyle is going to be changed after 5 years. Like I hope it's a general video available in the YouTube. I'll play this video and we can check it out.
When everything becomes linked with everything else, matter becomes mind, and the possibilities become endless. Imagine 50 billion IoT connected devices by 2020. Now, imagine the economic impact of these connected machines. $4 to $11 trillion per year by 2025. Wearable devices, environmental sensors, agricultural machinery, components in a vehicle, or devices in homes can all be connected to deliver insights and drive transformation. So imagine if you had smart devices in your home, your car, your workplace, or even on yourself. The world becomes alive. That's Internet of Things. The Internet of Things is making everyday objects into data factories. When Internet of Things, along with big data, meets artificial intelligence, this interface will become enlivened with intelligence, and a new world will take birth, which will increasingly talk back to us. Imagine the kind of world that it would be. Imagine the revolution it will usher in the way we see the world. The external world will become the extension of our mind, like an extension of our thoughts. Imagine a world that is responsive, a world that is optimized for human creativity, a world that is intelligent. The Internet of Things is a breeding ground for new AI-driven solutions and experiences, from self-driving cars to intelligent homes to health. Welcome to the world of endless possibilities. Welcome to AI and...
So yeah, this video was published by AI Summit Hyderabad. It's a wonderful thing to start our session with this video. So being such an informative about IoT, like what made it possible these days? Like IoT is there from like 10 years back. If you take, like, still IoT was there. Like still we had intranet connected devices like Bluetooth enabled devices or Wi-Fi enabled devices made with embedded C, or we can even say like microcontroller based devices. So it was there since long back, even before 10 years. But what's the hype now to get into IoT, to make it into automation? So the technologies that, as explained in the video, something like big data and something like artificial intelligence are the one now changing the game of IoT nowadays. So the lifestyle seems really good and the video seems really informative. As I said, yeah, it's really informative, it's good. Now, how do we start it? Like, it's good, it's been long back, it's there, we all know it, we are using it, we have smartwatches, we have smartphones, smart fridges, it's everywhere. So now let's see what's the fuzz about it. Like, everyone is talking about it, everyone is using about it, and how do we construct it? How it is built on the back end, and how it is managed, how it can be improved, and that's what we are going to see one by one in a theoretical manner of the whole session. So first thing is, we all need a plan, and we had something like Digital India, which is getting day by day better and better. And before we for even taking a driving license, we have to go to the RTO office and we have to wait, and everything was there. Now, like, I can just upload my like ID card and I can do it. So internet is a big fuss about this Digital India, and since like we are transforming into digitalization, the next step would be connecting things together. And yeah, now we need a plan. We need a plan to connect things to make India a IoT-fied place. So what is IoT? It describes a network of physical objects, or it can be anything. Object can be anything that are embedded with sensors or softwares and other technologies for the purpose of connecting and exchanging data with devices and systems. So in this phase, if you see this clearly, this IoT consists of different things. One is things itself, that's objects. It can be anything. It can be a phone, or it can be a fridge, it can be a washing machine, or your door, or your pet's collar, or your bathroom, or anything, or your smart meter. And the next one is sensors or softwares. These are real backbone of the technologies in the backend. Sensors are the hardware that we will be using to talk back to us to say like this is the situation, or this is going to happen, or like this is the data that we have. And the software is something that talks to the sensor and get back the data to us. And then when everything is connected, we get this thing called data. And later everything else is connected to the system. As a map, we see this explanation here. We are involving multiple technologies like embedded, software, and of course data, and of course systems. So that's what the whole thing is about now. Let's see one by one how this thing is actually connected and how it's going to be working. As first said, everything is connected, everything will be connected, or everyone will be connected. In recent days, if we check out, there are like some new innovation coming into market like Samsung tags, Airtel Apple i tags. So these tags can be connected to our keychain or our pet's collar or our kid's bag, anywhere, and we can track it back. And if it's like outside of our tracking zone, we can also raise a request so that people who are nearby can track it up. So everything will be connected here. And if you check, like, it can perform different option. It can check whether your door is locked or not. It can check like if it's rain, then instead of like not turning on your dryer, let's turn on the dryer, because if it's rain, then the clothes will be still wet. So it talks to the washing machine. And yeah, as I said, the dog's collar, you can attach the tags to the collar and you can search it up. So these are the different technologies that are coming into the market day by day. And now, let's say, as I said in the explanation, technologies that are linked to make the IoT working. And it's made up of 50% hardware in the sense like it can be a sensor, it can be a product, it can be anything. And software in the phase, it deals with programming languages, frameworks, and all the other algorithms that is developed on top of it. And also the remaining things comes with systems design. And systems in the case here, we deal with servers and networks. So if you ask me, of course, I am using my iPhone, I am using my iWatch. What a server to do there? Like, there is no use of a server for an iWatch. It's going to talk to my phone and my phone is going to say it back. Why do I need a server? And if the washing machine is turned on, it's going to be turned off when the process is done. Why do we need a server in that? Of course, there is a need in everything for a server. I'll explain you in detail when upcoming slides about how we use the servers to manage our little things. And hardware, we all know, yeah, IoT means hardware, hardware means IoT. That's the myth and like well-known thing about it. And software, of course, we all know the basic software that we are going to be using. Let's see in detail about what is going on and what is missing out there. So before getting into it, I have shared a poll with Dr. Ranjit. So can you please update the first question as the poll, like automation and IoT are same or not?
Yeah, the poll is there.
Yeah, the first one. Can we have a poll?
Yeah, the poll is on. The students can take the poll in the general tab. It will be there. Students can take it. Students, do you find this poll, guys? Yeah, there is one response, two response came here. Okay. The question is automation and IoT same? Okay, responses are coming. Jackson, I guess you can see this poll. It is in the main screen of this Microsoft Teams. You can minimize the main. Can you minimize the screen? You can see that.
Okay, let me check. I think I can't. It's
Right. Back of this page.
no, it's the app. It's directly in the app. So I think
Can you open one more time? Again. Open the tab. Microsoft Team. Not the. Can you open the Microsoft Team one more time? Double click on it.
yeah. No.
And not this one. I have to open another one window. New window.
So we click it. No. It's
You just double click on the icon on the desktop.
okay.
Yeah.
No. It's not allowing me.
It's great.
Sure.
I'll let you know.
You can announce the results of like is
Yes.
both are same.
Okay, we got 81% says no and 18% says yes.
Great.
The question is automation and IoT same? And yes by 18% and no by 83%.
Okay, so yeah, that's correct. IoT and automation are not the same. Using IoT, we can like it's a tool. Using IoT, we can do automation, but it's not the same. Good job, guys. Hope we are on the track. So let's go to the next thing. That's hardware and the sensors. So here on the hardware and the sensors, we look upon like what are the hardware that we use for doing um, the project or doing an architecture out. So here in this case study, we'll see like different sensors that's available. One would be like a temperature sensor or a pressure sensor or a proximity sensor, gyroscope sensor or infrared sensor. So like using the different sensor, we can apply it in a different field. Let's say that we have a temperature sensor installed in our oven. So in the oven, like once the dish is performed or um, once the dish is performed but still the oven is out of heat or out of sync, it is still on the heat, it's malfunctioning, then we can notify them, hello user, your oven is malfunctioning. So this is a small example for saving a life. And let's say gyroscope sensor or let's say accelerator sensor. So it's a common interesting fact that insurance companies are really common in the US, not in India. But how do they do it? Like a lot of people claim insurance for accidents and they claim their money back. And the company is facing a lot of loss due to this. Of course, it's an insurance company and it should give the money back. That's the rule. But according to the company's statistics, they are giving away more than money what they are getting inside. So that's a loss for the company. So in order to come out of it, what they did is in this case study, they used gyroscope sensor where it defines also the proximity sensor. It defines these two sensors are also available in your phone. Okay, so they develop their app and they define the position of it. So using the position, they can identify whether the driver is driving slowly or in the correct speed limit, or is he a rash driver, or is he a perfect driver, is he a drunken driver, and everything. So how can this be performed? Can anyone tell me an idea? Like this sensor gives the data. So how do they perform this thing? Can anyone come up like, yeah, there are sensors. These sensors give the data, and of course the insurance company is going to get the data. So how this can be applied? How can we save the company?
Sir, the sensor data can be continuously monitored over time through the cloud,
Mhm.
and they can check whether the value should be in the threshold limit or not. If it is not like that, when the accident took place, then they can reject the insurance claim, sir.
Nice. So yeah, that's a good answer. It can be taken to cloud and it can be processed. So it was a good answer. It was a like yeah, it's a good answer. So that's what actually they are doing, but in a well-versed manner. Instead of using condition, we'll be using machine learning on the back end to make sure that the process is correctly monitored, and the analytics on the top of it will decide whether the group of driver or rash drivers, the group of drivers are drunken drivers or others. So how do we do that? First thing, let us take some testing cars. Okay, let's take some 10 testing cars, and not 10, let's take more than that. Okay, let's take some 1,000 cars. So we are asking 1,000 volunteers to come in. Out of 1,000 volunteers, 250 are rash drivers, 250 are slow drivers, 250 are drunken drivers, and 250 are drivers with physical like physical inabilities, like people who can't see clearly, or people who you know drive with one hand, like who doesn't have a hand, or people who drive automatic cars because they are physically impaired. Okay, so those drivers. So what we do, we give the app to them installed in it. We are going to take a survey now. So this is a case study. In this case study, we are taking 1,000 drivers and splitting into 4 different groups. In the 4 different groups, we are giving them same sensors like gyroscope and proximity, and yeah, of course, and we are going to test them for 150 kilometers. So all these drivers are going to drive for 150 kilometers, and we are going to check like what is the data that we get from them. And once the data is taken from them, this is called test data. And this test data will be used to develop the decision making software that is running on the back end. So how the decision making software is made, that is with the help of machine learning, or in the best case deep learning. So the algorithms will be applied on top of it. Mostly we can use CNN. That's a good deep learning algorithm because it is really good in handling matrices. So we'll be using CNN. And CNN, like, because there are like few different algorithms. I'll explain why CNN and why not CNN. So now let's take CNN. So this algorithm will learn the pattern. 250 drivers who are drunk have this pattern of driving, like wobbling, going fast, then stopping it, or like going extremely fast, or like when they see a car in the opposite, they just apply the brake so fastly. So they are different from the rash drivers. Rash drivers are completely controlled when they drive the car, and like even though they apply brake faster, even they do like they cross the speed limit or anything, they are still in the control by their experience. But drunken drivers are someone who are not on their control but try to be on their control while being the rash. So those data will be grouped up, and impaired drivers 250, their data will be taken like A, B, C, D, and based on that we will find a pattern out of it. So how the driver driving, the pattern I explained: controlled, not controlled, and of course people who are driving smooth. So this will be trained with the CNN in the backend, and it would be hosted in the cloud. Okay, so it will be hosted in the cloud. And whenever we install the insurance app and they keep the phone in their car and start to drive, the sensors in the phone let's keep it this way. Sensors mean not the sensors that we see here. Sensors mean not only the sensors that we connect to Raspberry Pi or Jetson or something else. Sensors are available even in our smartphones, even in our headphones. Do you guys know Apple AirPods even track the data of how users are comfortable in the position of hearing music? Are they comfortable by sitting? Are they comfortable in walking? Are they comfortable in like laying down? So they can even track your head position. By that head position, they will tell you that we are giving you immense audio experience, but they're actually tracking your head position. So sensors is everywhere. It can be used in this way also. Coming back to this case study, then this mobile app will be installed in the system in your phone, and your phone will be kept in your dashboard of the car. Of course, whenever we drive, we keep the phone in the dashboard or our pocket. And then when we drive it, automatically what happens, it will take our data now, and then it will send it to the servers. And now our CNN, which is already pre-trained, which already knows which type of drives the car, will reciprocally sends the data back. Hey man, you are drunk now, so if you met with an accident, you will not be claimed. And trust me or not, this model actually saved 50 million US dollars for the company in 1 month. So this is a case study. So do you have any questions regarding this case study? Any question how they handle it or how they handle the traffic and everything? Okay, so let's move to the next one. And these are software, these are the hardwares and the sensors that are used for development purpose. Again, I'm repeating, these are for development purpose. And sensors that's on the real world are completely different from what we see. Again, coming here, these are common sensors and these are most common devices. Sorry for my mistake on the presentation. These are common devices. One is Raspberry Pi. It's a microcontroller enabled smart computer where you can, it runs on Linux. So you can just run your code and you can connect it to the hardware using the GPIO pins. And of course, Jetson Nano is a NVIDIA device. And the best part of NVIDIA devices, it's a bit costlier than Raspberry Pi. Like if your Raspberry Pi is 3.5K, your Jetson Nano cost about 7.5K. But the best part is it has inbuilt GPU. So if you are doing any deep learning based operations, like if you are creating a self-driving car prototype, or if you are creating any robot that can walk and talk, so your Jetson Nano will be a perfect device for you to do that. Or if you're just building a smart home, or if you're just building a smart, a smart intelligent system, then Raspberry Pi should be enough. And Intel Galileo is kind of a more powerful system. It consists of its special softwares and hardwares prepared by Intel on its drivers. So if you are creating a hospital management system, then your Raspberry Pi will not actually, it will give up. So it's not that much powerful. If you're creating a hospital management system where all the rooms are connected, where all the patient data are connected, it's a huge data, right? So it's a powerful thing. So on that case, we'll be using Intel Galileo. So that's a powerful one. We also have Dell Edge and everything up there. So that's about small computers. Now let's go to softwares. So how many of you are common with this technologies here? So I'll raise up another poll to know about it. Sir, Dr. Ranjit sir, can you please update the second question? Like Python can access hardware.
Right. Students, kindly find the second poll. In the general tab, you can find the question. Right. Okay. So you got two students. All of you, can you take this one? 80% for yes, Python can access. 20% no, C can access. Python can access hardware. Okay, so no, only C can access. That's like 14%. Yes, Python can access 71%.
Good.
And others, say it's like 11%.
Oh, so I think
Okay.
yeah, nice. A decent number. 70 is a decent number, I
Yes.
think. So yeah, good job, guys. Again, so yeah, Python can access hardware because Python is written on top of C program, so C programming language. So it can access. Going back here, technologies applied. First, we saw what is the hardware and how it can be, where it can be used. Now we are seeing the softwares. On the software part, we need something that is really good and really fast and light. You can say that, sir, Java is faster, then why are we using Python? Java is really good, like Java is faster than everything. The worst part is Python is interpreted and Java is compiled. So Python is called all-purpose language. So if you want to run Python, you can just install the interpreter of Python, which is like now it's like 30 MB or 40 MB. That's it, and it will run it. But in order to run your Java machine, of course, Java is faster once it's converted into binary code. But your JVM is too much harder. Like the JVM takes a lot of virtualizations to run the code, and when it comes to higher performance, then of course Java is not a good answer. Or some other language, let's say Go, or let's say any other language, Ruby, because Ruby cannot talk to hardware, so we can't use Ruby. So why Python? Yes, of course. Two important things, as I said. One is Python, general purpose language. It can be used in web, it can be used in hardware, it can be used in scalability. When we are writing automation task, Python can be used in scalability. Python is also really good in networking. So if you take networking, then we have to go for C, C++ in the most cases. So instead of using multiple languages on multiple location, the community decided to go with Python because there are, like, it's easy. If you want to write for network, of course, here. You want to write a scalable system, yeah, Python can do it. You want to write a data science operation like a deep learning system, yeah, Python can do it. If you want to write a web application, Python can do it. Do you want to write a application programming interface, API? Python can do it. So that is the reason Python was mostly used when it come to Internet of Things in the best case. And it is also really easy. Easy is a second part. Than that, there is something called patterns in development. So we have several patterns in development, and when it comes to patterns, Python is really good in holding that pattern. It can be both object oriented and it can be both method oriented. So you can call, like, object oriented is a really good option, but when it come to this kind of IoT development, mostly we would prefer method oriented development architecture. Why? Because when it come to functional programming, every function deals with every other function without interrelated to each other. But when it comes to object oriented programming, even though the function inside a class is interrelated, sorry, even though the class and class is not interrelated, all the functions inside the class will be related and passed in a single class. So if you take the class, then all the functions inside the class as an object are related to each other. That's how the patterns are built. But when it comes to method oriented programming, it's not like that. Only the function is the one that is capable of doing it. So that is the best part of choosing Python 2. So I hope I'm making my sense clear. Difference between object oriented and function oriented. When we are developing softwares like enterprise level softwares, usually company prefers object oriented programming in development. But when it comes to uh, like hardware oriented programming, functional programming plays the best part because it doesn't have interrelativity, coherency, correlation much than object oriented. So I'm making my point clear again. And also this part, coming back, there is one more language which is a star, that's embedded C, of course. It's a DIY kind of language. You have to rewrite everything of your own. You have to manage it on your own, declaring a variables type to getting a REST API. This is going to be a headache because in Python, when you read in REST API, automatically we can convert that into dictionary and you can use it. So do anyone have idea about what is REST API? Anyone here? What is REST API? What is SOAP? What is gRPC? I'm sorry. Can anyone come up? Okay. So API is something where one software can talk to other software. So even now we are using REST API to establish this call where one end of user is going to talk to other user. So our data is going to be transferred through API. We have one software which is taking the temperature of the home. We have other software which is checking the washing machine, and we have other software installed in the phone. How do we connect it? How one talk to other? As a humans, we have a language, and that language has something called grammar. Without grammar, if I start to spill out the word like hello, hi, hey, hi, who, nothing makes sense. So the same thing, we have programming languages. That language is going to take care of talking to the self, but when it comes to talking to someone else, we need good grammar and we need a common language. So in India, people are from different states. Like if I have to go to North India, or if someone from North India come down here, we have a common language, and that common language can be Hindi, of course. And if we go to Europe or US, we have a common language called English. Same thing, when this hardware which monitors my washing machine, or this hardware which software which monitors my temperature, and this software which is on my phone, these are foreign language speaking softwares. And when they talk to each other, they need a common interface. Let's take an example. This is a website called macro.com.br. It's a Brazil website, and when we go here, let's open the website. So it's an online shopping cart. Come on, this should be the one. Cool. So in this website, it's showing the products. Okay, it is showing the products, and if you see here, this website is developed with the help of React.js. React is a front-end software, like it's a front-end framework. Okay, and the backend can be developed with the help of, like it could be developed with the help of Java, or it can be helped with the help of Python. So these are two different languages. One is Java or Python or Ruby or PHP, which is backend, which is talking to the database, and the front end is React.js, which is a HTML, CSS, JavaScript, and everything. Both are two different languages. But when I open this one, it is loading and it is giving me the data. So how this is happening? Let me open my inspect. So you can open this tool and you can check what is actually happening. So if you go here, we can see, this is made up of React.js, so it has all the components here. Okay, so it has, service, it has memory, and you can check the network here. So when the network is here, when I refresh this thing, you can see in the network, it is making some calls. It is making some calls like, .js, and yeah, so you can see like it's making some different calls. What is happening in the backend? Why it is calling? If I'm calling, it means I want to talk to someone. Okay, so what this software is doing here, now this website needs to talk to someone in the backend. So let's see, who is this website talking to? Who are you talking to? Let's find out what this website is and who this website is talking to. Okay, and now I'll just refresh this page, and then now we see here and we get it. So let's see, it should be something like API. Just give me a minute. Yeah, so let's see what this is talking to. Preview slug. It should consist of a API. Just a second. Just give me a minute. Let me take that API out. Yeah. No, not this one. This one is this one. Yeah. So here, if you check, now let's go here, go to here. Okay. Now this is my data that is coming from the backend, and the category is Pasoka. I'm not sure. It's a different language. It's Portuguese. And now let me go here and see what we have here. Takes time. Let it load. Okay. Okay, it's taking time. Just give me a second. It should be working. So this is software. Let me check with other URL. It should be working. Okay, let's go here to the home. There is something called, oh, here it is. Yeah, Asaka, and this is the cool. Sorry, that's my mistake. So here we have this one called Ovinos the chocolate, and let me search here. If you see here, here is the product, and if you check here, see, I have the image, and here it is displaying the image, and it's in the format of JSON. So if you know about, this is in the format of JSON. And here, if I check this one here again, this is the product. I saw how the image looked like, and now I can see what's the price. It's 6.9 rupees, sorry, 6.9 pesos. So here it is, 6.9 pesos per piece. So there is something called backend, which is in Python, and there is something called frontend, which is in React.js. Two different technologies, and how they are talking to each other using this thing called API, application programming interface. This is how it looks like. So as we talk, since it's a GET request, we can see this in the browser. If it is not a GET request, we cannot see this in the browser. Do anyone have any questions? Any questions? This is the app as the backend, and this will be the API. Yeah. So this is how it looked like. Front end, and this is the back end. And that thing, you guys might have been familiar with this diagram, front end, back end, 3-tier architecture, MVC, but this is how the MVC looks like. This is how even our IoT apps are going to talk to each other. So it's like an entity where this will be our hardware, and this will be our servers, and that's how, using the JSON, which is REST enabled service, they are going to talk to each other. Okay, any questions? Hello, any questions or doubts?
Students, do you have any questions, guys?
No, sir.
Okay, good. So we saw Python, we have C, and then like the next one is microservices, which I showed just now. The microservices that we saw was actually REST. And there is one more thing called gRPC. So now which thing I showed you is called external call, which means that I have one on my washing machine, one sensor on my home, and one software on my app. So this REST API which I showed you collects the data from my home, put it in my some server in the cloud, and that is actually, again, it's connected to my phone. So this external connectivity can be handled with the help of REST API. But there is something called internal connectivity. What is internal connectivity? If the door is open, then it means that turn on the camera and check whose face it is. So when I open the door, automatically my camera opens up, it detects my face, and then it detects this is the owner of the house. Then let's turn on the lights. This is next step. Lights turned on. And then when I get in, turn on the heater. So let me take a bath. Next step. So which means one sensor or one thing, hardware, is going to talk to other, and this should be handled in a fraction of seconds. As you saw, when I opened this website, it literally took me more than 3 to 4 seconds to do this thing, and my speed is really a decent one. Internet speed test, it should show here on a decent speed, even though it took 1 to 2 seconds to load the data. Think about having the same thing in your house. When I'm walking in, door is not opening up. I'm just pulling it harder. It takes 2 minutes to go to the server to check out, even in 100 Mbps. And of course, again, opening up, it takes 2 seconds to turn on the light. Like when I say 2 seconds, it might be like 2 seconds is not a big deal, man. Like it can be taken care. But what happens 2 second after 2 second after 2 second? 2 seconds to open the door, 2 seconds to turn on the lights, 2 seconds to turn on the heater, 2 seconds to turn on the coffee. Like 2 into 2 into 2, that is exponential increment. And REST API is the real reason that is slowing down our system. So in the REST API, we saw the data was on JSON. We can also use XML, that's a different opinion. Let's not get into there. And now in gRPC, the API is in binary form. We cannot see it. Okay, I cannot show you in the browser. If you guys are really interested into it, you can check out into it. This is developed by Google and maintained by Google. So this gRPC is a binary API where it is 10 times faster than REST API. Let's say if 200 REST API calls are made in 1 second, it can make 2000 API calls in 1 second, which means everything happens in instant. Like everything happens in instant. The most of the professionals who doesn't speak up about gRPC in such webinars, but I thought like maybe it's a good chance for you guys to learn about this one. So it is really faster than REST API. It is used for internal communication and it is not used for external communication. What is internal communication? If my door is talking to my fridge and my fridge is talking to my bathroom, that is internal communication. If my door and fridge and washing machine is talking to the server and the server is talking to my phone, that is external communication, something that is happening outside of my house. Any questions? Any questions about microservices? Okay, cool. So if you have questions, feel free to ask. I'll help you out on this. And the next thing, first we saw the hardware. First we saw hardware and the software that is going to write on top of it. It can be embedded C or it can be Python, mostly Python. And then we write on top of it and we get the data from it. And then we talk to each other. So 3 things has been done. And the next thing is data science or data analytics. So this thing is the creamy layer on any IoT which makes it more interesting. As I said, data science consists of different algorithms. So as a data science, it consists of different part of exploration. One is data engineering, data analytics, and deep learning. So in data science, data engineering is mostly on collecting the data and structurizing the data and then applying algorithms on top of it. So different algorithms, same machine learning algorithms. And data analytics is applying statistics on top of it and bringing out the graphs and bringing out the exploitation of the data. And data science, the third one is deep learning or machine learning, which means that what are we going to do with the data? So we have the data, it is structured, we are applying the algorithm on top of it, we are seeing everything, it's good. Okay, fine, what are we going to do with it? So as I said again, we have the fridge, we have the phone, we have the everything is connected now, everything is talking to each other, and what are we going to do with it? Okay, so that's where this thing comes into picture. So here we have different things in data science. As we mostly use frameworks for doing these operations. For data analytics, we'll be using frameworks like pandas in the best case. We have also like TensorFlow, Keras can also be used for data analytics, and also a few things out of it. We have NumPy to do the data operations and manipulations. We also have Matplotlib. We also have Spassy. These are different libraries that can be used for doing these operations. And as I said, the important algorithms that are mostly used in deep learning are convolution neural networks and recurrence neural network. Convolution neural networks are really good in handling image-based or multi-dimensional based data. So as I said, sensors gives you multi-dimension data. What are multi-dimension data? Data, if I take gyroscopic sensor, it is going to give me the axis of x-axis, y-axis, and z-axis. So which means that it's a 3x3 matrix. So that's a multi-dimension. And if you take an image, if an image is like 28 x 28 pixels, it's 28 rows and 28 columns. It's a multi-dimension. So CNN is really good in that one. And RNN is really good in not multi-dimension, but uh, we call this like series of data, like stock market based data, which is like series. And if we take climate changing data, that is series. And if we take satellite revolution, that is series. These kind of series data, it is good in RNN. So for doing the CNN RNN, we'll be using frameworks such as TensorFlow, Keras, and Coffee, and a lot. So that's all about here. And the next one is systems design. Coming back here, systems design, what happens in 1 second of the internet? So this is a famous thing. If you check here, the population of the world is 7.1 billion, and people who are online in 1 second is 3.4 billion people are online now as we are talking. So now let's imagine that every people have 5 devices connected. So I have my watch connected, I have my phone connected, I have my laptop connected, and my desktop connected. Phone, watch, laptop, desktop, and of course, let's say my smartwatch. So 5 devices. Imagine 3.4 billion people connecting 5 devices in the internet. So that's this much of devices. And we cannot even say the number. It's 17 billion. So, and the interesting part is this numbers, this statistics was of 2017 and we are now living in 2021. In this year, if you check out, a lot of people started using internet, very large number of people. So how our Raspberry Pi is going to handle that much pressure? It's a small computer. How our phone is going to handle that much pressure? It's a small CPU. So in order to do that, we will be using servers. And when we call server, if we set up a whole server, it takes a lot of time. Let's say if I have to set up a data center of 1000 square feet, let's say 1000 square feet, 1000 cross 1000 square feet, okay? So the cost of 1000 cross 1000 square feet server which I'm setting up would nearly cost me more than 8,000 crores for just 1000 square feet. So imagine I'm starting a own IoT based software company and I need servers. How is it possible? So we all came to know that Jeff Bezos became billionaire and billionaire. Do you guys know, like, AWS is the main reason for him to become a billionaire? And can you tell me one or two softwares that are hosted in AWS? Softwares that we use in real time that are not using their own server. Like, let's take a company, if Google, like, let's take a company, it can be any company, they have a software that we are using it, and that company is not having their own server. Instead, they are using AWS. Can you tell me any one famous company or two famous company?
Netflix, Spotify.
Yeah, Netflix, Spotify, Hotstar, everything is hosted on AWS. And we are using it day by day. And if Netflix is making profit, absolutely AWS is making profit. If Snyder's Cut is released, of course Hotstar is making profit, and also AWS is making profit. And the best part is here, they have all the tools required. We don't have to install anything there. So now, sir, for the last thing, as the end of the session, we have 5 more minutes. I'll complete the session with a introduction to AWS and Azure. So the last thing, sir, Ranjit sir, can you put the last poll, that is what is
Sure.
cloud computing? And
Yes, I'm putting it. Yes. Students, there is a last poll for you guys. The question is, what is cloud computing? Okay. 75% or 80% is like Google Drive or Dropbox, and 33% says like others. 50% says like, yeah, it's like Google Drive and Dropbox.
Okay, so
And
the options are like someone's computer, like Google Drive, and others, right? Three.
others, yes, sir.
Okay, so actually the answer is someone's computer.
Okay.
So the answer is someone's computer. Like Google Drive or these things are also someone's computer, or also in someone's computer's hard disk. That's it. So basically, a cloud computing can be a hardware as a service or a software as a service. It can be a computing as a service. It can be a anything. Like you can, you know, you're actually accessing a AWS computer, Amazon's computer, which is hosted in Mumbai or which is hosted in California or Texas or everywhere. Okay, that's actually someone's computer. So taking this to next level, instead of just giving us their data disk drive, so instead of just giving us their drive, they are giving their processor, they are giving their RAM, they are giving their everything, like graphics card, and they are giving their, you know, computing power to us. So that's cloud basically. So it can be anything. It does not mean that it's just only Google Drive or these things. These are like just storage as a service where you can store the data. Okay, so we are just using their hard drive. If you use Google Cloud, you can use their processor also. Okay, so now we are just storing it, the data, like you're only using their hard drive. If you need, you can use their processor and RAM also. Okay, so it's basically someone's computer. Of course, it's running on somewhere else. That's virtualization technology. When it comes into bigger picture, we'll maybe, if time permits, in some other time we can look deeper upon it. So here we have RTOS, Greengrass, IoT Core, and everything here. And also there is one more thing I forget to add, which is called AWS Lambda. So when there are multiple devices connected to each other, what happens in the AWS? If 50 users are using, we need that much of computing power. If 50,000 users are using, then it should be like that much of computing power. And imagine that if I'm subscribing for 50,000 users and only 50 users are using, 50,000 users are going to use only on Big Billion Day sale. In other days, there are only 5,000 users, but I'm still paying 50,000 rupees. So instead, if you use AWS Lambda, it's a scalable computing. It will charge you based on how much resources used. That's it. And also the best part is does not even slow down your software. How many even numbers of like people are using it, the software keeps on scaling up. It's AWS Lambda. So of course you can use that for your multi-computing architecture using IoT. And also they have, like, you don't have to write your own deep learning algorithms. They also have their own cognitive services, they call. So you can just upload the image, it will recognize your face. You can just upload your audio, it will recognize the voice and everything. So that's also the best part about AWS. And same thing with Azure. Azure is a Microsoft provided service, and also it is still, you can do anything with it. You can have a hub. What is a hub? Hub is a connection of multiple devices together. Let's say hundreds of houses are using it and hundreds of devices are connected to each other. Let's say Alexa, hundreds of Alexa connected together is called Alexa hub. Okay, and what is a central? Multiple number of hubs controlled and updated via a central. Okay, and that central will push the changes to the hub. Okay, so it's like connected to each other. So it's like you don't have to update each hub. There can be 1,000 hubs. Okay, and we can have 2 to 3 centrals, where if one central is updated, that is going to reflect on other two things. This is called scalability. So that's how it goes on. And also we have Azure Analytics. This is not here. We can also see the analytics of how many hardwares are being in use, how many hardwares are not being in use. So those things also comes into picture. And how is the future look like? The revenue is, of course, 1.1 trillion US dollars in 2025. This is approximate. It can be more than that. of course. And combined, it's not only in India, it's all over the world. It's like billions and billions of dollars. That's 25 billion in total IoT devices will be established within 2025. And of course, I can assure you, the number will be more than that. So if you prepare yourself to be an IoT developer, you can focus on the components that we discussed, whether on the programming languages, or whether on the microservices, or whether on the systems design, or whether on the data science field. These things cannot be replaced by robots ever. But this software development and project management will be automated within 2 to 3 years in the whole market, and there will be like project management will be completely automated soon, and sooner than ever it will happen. So this is how this keeps on going. And thank you for the session. If you guys have any question, or if you guys have anything to ask to me, you can ask.
Dear students, this platform is open for questions. If you have any questions, kindly come forward.
If nobody have any question, like anyone can come forward and say, summarize the whole session. Like, what are the 3 things we saw? It's so easy.
I guess nobody's coming in.
Okay.
Guys, do you have a question, or shall we wind up the session? Yeah, but I will. What I can do is like I will take the question if they have, and I'll mail you back, Jackson.
Sure.
Right? Yeah.
Thank you so much.
It's given me an immense pleasure to convey the vote of thanks of the session today. And indeed, it was a great session, Jackson, and it was a great takeaway for us. And you have started with the introduction of IoT, then you have said about APIs, and you have said a lot about REST and gRPC and about cloud computing. It's a good takeaway for us. And thank you for your session. Thank you, Jackson.
Thank you, sir. Thank you everyone for this wonderful session.
Thank you, dear students, for joining this session. And have a great weekend, both of you, Jack and all the students. Bye all.